So here we have a chart that talks about the degree of polynomials. It gives us types of polynomials. There's some examples, and also something about standard form. And then there's something about name over there, which I'm gonna fill out when we get to that part. So first thing I'm gonna do is just talk about the degree. The degree is the highest variable amount in any of the terms. The highest variable amount. And in order to determine the degree, you have to know what a term is. So I better define that up here just in case. A term in polynomial are separated by addition or subtraction. Terms are separated by addition or subtraction. Okay, here I have terms separated by plus or by addition or subtraction. So when you're looking at these standard forms here, you look at these standard forms. Is there any addition or subtraction in this first one? No. Easy question. Any plus or minus sign? And how many terms are in that first one? You know what it's called if it has one term? Starts with N? Monomial? How come I don't hear you? Alright, if you look at this example for the linear has a degree of 1. That means that out of the terms we have, the highest exponent, the highest amount of variables in any of the terms is 1. And we've graphed these, they look like lines. So here I've got an x to the first. And in the other term, there's nothing. There's no x's in it. There's just a constant. How many terms are in this example right here? What's it called if we have 2 terms? Binomial. What's it called if we have 3 terms? Trinomial. What's it called if we have 4 terms? It's just called a polynomial. We stopped having special names after trinomial, but I like to hear what you guys come up with. So any terms, the number of terms, any terms for n terms, it's a polynomial. Okay. N terms, number, okay. And going back over here, if we have a degree of 2, that would be quadratic. Those were those ones that we were graphing recently that had those parabola shape. We have not graphed higher than that, but now we're working on it. So today, if you have an exponent, the highest amount of exponents in one of the terms is 3, that's going to make it cubic. If you have the highest amount of exponents in one term is 4, it's going to be quadratic. I lied. Quartic. Quartic. I just automatically want to say quadratic, but that means 2. Quartic means 4. Okay. To be in standard form, the powers, the degree, the exponents have to be in descending order. So you can kind of see that in these examples. We've got, like in cubic, we've got x to the third, then we've got x to the second, then we've got x to the first, and we have no x's. So they go in descending order. So this is all vocabulary. Let's see if you understand both. Oh, wait, just kidding. I got one more thing to say about polynomials. It's not written here, but I need to say it. Sometimes, like in these next few examples, they're going to give you things that are not polynomials. They're going to look like polynomials, but they're not polynomials. Let me give you a few characteristics. If you see them, they're not polynomials. If we have variables in the exponent spot, the 2 to the x, those variables in the exponent spot, that's not a polynomial. So here's an example. Not a polynomial would have something like 2 to the x. Another not polynomial would be variables have exponents that are negative. I totally wrote that in a weird way. Variables have negative exponents, I should say. If the variables have negative exponents, not a polynomial. We have a variable in a denominator, like in the bottom of the fraction, not a polynomial. If you see a variable under a root, under like a square root, not a polynomial. There's other things that could be not polynomials. I just don't know how many we're going to actually see, so I'm going to leave it for there, like right there for now. Handwriting issues?
No,
My handwriting
I was confused about the under the root.
Like under a square root of x, that would not be a polynomial.
Okay.
You'll see examples. You'll see examples of what I'm talking about. I just want you to have those in your notes, so when you're doing your assignment, you have that handy. Of course, you can look it all up on the internet if you don't write it down. All right, decide whether each function is a polynomial function. If so, write it in standard form and state its degree, type, and leading coefficient. So we look at this first one, and we're looking for those what makes it not a polynomial. Do you think this is a polynomial? What do you think? Yes, it is a polynomial. So if you write in standard form means you have to have the highest x's first, all the way down to the lowest amount of x's in the terms. So we're going to put negative 2x to the third first, because that's 3 x's, plus 5x, because there's 1 x, plus 8, because there's no x's. You put it in that order, that's standard form. Yeah, that one was already in standard form. They're not always in standard form. Next thing we need to do, if it is a polynomial, we need to state its degree. So what is the highest amount of variables in that first term? 3. So the degree is 3. Then we have to talk about its type. What has a degree of 3? What kind has a degree of 3? Cubic. Cubic. Also, how many terms does it have? 3. So it is a cubic trinomial. Degree of 3 and 3 terms. Cubic trinomial. And then finally, our leading coefficient. I'm not writing all the way out. Leading coefficient. Leading coefficient would be the coefficient of the first term. The one that has the degree in it. What's the number in front of that? -2. All right. Number B. Letter B. Is this a polynomial? Why not? Is the variable under the square root? You see how this is misleading. That's why I tell you to put stuff that's not under the square root in front so we have no confusion. The book did not do that, so I'm just rewriting that term. Now, do you think it is a polynomial? Yes. The variable is not under the square root, so we are okay. This is a polynomial. We're going to rewrite it in the correct order. So which term has to come first? The one with the x to the fourth. So x to the fourth radical 2 would be our first term. then minus 0.8 x to the third, then minus 12. So we're having our descending powers of our x's. So our degree is how many x's? 4. That makes the type quartic. And then that's on that table, so you don't have to memorize it. It's on the table. And then how many terms does this one have? 3, so quartic trinomial. And then our leading coefficient is the coefficient for the first term. And I moved it so it's not in the front, but it is in the first term. What is it? Square root 2, or radical 2. Okay, next one. H of x. Is that a polynomial? Not a polynomial. Why? Why'd you say what? Why'd you say no? There's an exponent that's negative on the variable. On the variable. Like it matters that it's on the variable. So because variable has exponent that is negative. If you were to tell me the exponent is negative, that's not enough to say it's not a polynomial. It has to be the variable has an exponent that's negative. Also, you should not just write not polynomial. See how I modeled for you and I wrote because? That's what I expect you to do in your assignment. So do your notes that way too. How about D? Is D a polynomial? I see heads shaking both ways. What do you think? Why? Right, we can't have a variable as the exponent to be a polynomial. So not a polynomial because variable is the exponent. And that can't happen. Yep. Try the next three. First. Oh, because that's in the first term. It's the number. I mean, it can be written in front. It's just okay. Confusing. That is in front. Okay. But it's still the number multiplied by that first variable. Okay. So decide whether the function is a polynomial. If it's not, please tell me why. If it is, figure out all that information. Take good notes so that you have it to do your assignment tonight. All right, example 2 says evaluating a polynomial. So evaluating means to find a value. We're going to have one number. This says we're going to find a value when x equals 3. So you are going to have to show at least one step. So your work should look like this. F of 3, wherever there's an x, I'm going to make it 3. Equals 2 parentheses 3 to the 4th minus 8 parentheses 3 squared plus 5 parentheses 3 minus 7. Now, how you find the answer from there is up to you. If you want a challenge, you want to do it all by hand, feel free. If you want to type it in your calculator, that's more than fine. But remember, f of 3 is directions. It's saying what we plugged in. You only plug in the right side, and you need to put the parentheses where they are. If you leave them out, you'll probably get something wrong here and there. So go ahead and find the answer. All the steps in between, you don't necessarily need to show those. I showed those because I was doing it by hand. If you type it in your calculator, you need to show the first step and the last step. So notice how I have my answer as f of 3 equals 98, so everybody can see what you had typed in. You typed in 3 correct. Then you got out 98. Don't just write 98. You already said it. Oh, you fixed it. 68. Yeah. Well, it should be plus 5 right there, yeah. Plus 5. All right, so that was really hard. Can you try 2 more? You can do it, and then we'll dance. 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 Dance for it. Oops, I skipped something. Any questions on these? We're just plugging in the number. Please just show like your first step that shows what you plugged in, and your last step showing what you plugged in and what you got out. If you're doing it by hand for practice, because you know you want to be in pre-calc next year, and in pre-calc there's a lot of non-calculator tests and quizzes, then you can show more work. That's fine if you're just doing it on your calculator because you're not planning on, doing anything with math someday. That's fine too. We'll pause it because we got to dance. We got to dance. It's very important. So those of you watching the video, you're missing this. Hey, that should have woken you up. So this is called end behavior. This is called end behavior, and you will see some fun looking symbols there. What is it called when we got the sideways 8 thing? Not sideways 8. What is that? Infinity. What if there's a negative in front? Negative infinity. Negative infinity is either left or down. One or the other. Negative infinity, left or down. Positive infinity is right or up. And I say or because we're going to talk about x's versus y's. So we have 4 situations that we just danced. The first one is a degree that is odd. Could be linear, could be cubic, could be quintic, or so on. And the leading coefficient is positive, so as you're reading it, it's going up. The second one over here is odd, So we still have that same shape, except for the leading coefficient is negative, so it's going down. The third one is even, so we've got two both going the same way, and this one's positive, so up, up. And then the last one is degree even, so, and leading coefficient negative, down, down. All the stuff we just did. So there's two pieces of information that you have to find to know the end behavior. Degree and leading coefficient. Now these symbols are the part that seems really confusing, but I promise it's not. What does f of x stand for? Y. So every place you see an f of x up here, it's talking about y. When there's an arrow, it's saying the direction it's going. So like it doesn't, and I don't mean right. I mean like it means going to. The arrow means going to. It means approaches. Going to. Okay. And then negative infinity. And then as x approaches negative infinity. The second part's really important. As x approaches negative infinity is which direction? X goes to negative infinity. X goes to negative infinity is what direction? Left. Should we Tootsie Roll next? Alright, later. So when you look at this one and you look at the first part, it says f of x, so that means y goes to positive infinity, which means up. This one's down. And then as x approaches positive infinity, that means right. Now, when you look at the next one, this one is saying y, and then it says positive infinity, so it goes up. And then the bottom part says as x goes to negative infinity. So x going to negative infinity is left. Then we've got y goes down as x goes to the right. Then the next one, we've got y goes up as x goes to negative infinity, so the left. And then over here, as x goes to positive infinity, is the right. I know you all can tell me with your bodies what it does. You have to be able to tell me in symbols. But you'll notice in blue, every single one of them has left first and right second. Every single one of them has left first and right second. So I'm going to keep it in that same order the whole time. I'm going to do examples. So these are here if you need them, but I just feel like doing examples is better. So let's do a couple examples. This first one, if I can turn page. Example 3, describe the end behavior of the graph. F of x equals negative 0.5x to the fourth plus 2.5x squared plus x minus 1. First thing is it in the correct order? Okay, because if it's not, you're going to get it wrong. Then the next thing we have to do is determine the degree and the leading coefficient. What's the degree? What is the highest amount of x's in that first term? 4. So my degree is 4. Is that even or odd? Even. Next thing we need to do is determine the leading coefficient. Negative 0.5, is that positive or negative? Negative. So could you show me with your arms even, negative? Where's that go? All right, excellent. So my graph will look something like that at the ends. I don't know what's happening in the middle. We're not there yet for the middle. We're just talking about the end behavior. So I might do some fun stuff in the middle, but for the ends, that's what it's going to do. So on the left side, over here, on the left side, we're always going to start with y. So we're going to start with f of x. Approaches. Where is y going on this side? Up or down? Down. Negative infinity. And then you write as. Then you talk about x second. Where does x go on the left? X left is, which infinity is left? Negative infinity. You just have to know which infinity it is. So if it's left, this is the left side over here, right? Correct, I mean? Not right. So on the right side, we're going to talk about f of x first. So you look at the picture, and we're talking about f of x, that's y. Is it going up or down on the right? Down is negative infinity. And you write as x approaches, now we're going to the right, so x has to go positive infinity. That is end behavior. What does that arrow mean? Approaching, going towards. What does f of x mean? Means y. What does negative infinity tell us? Where's negative infinity? Negative infinity? Where's negative infinity? Help me. Down or left? Depending on you're talking about x or y. Okay, describe the end behavior of the graph of f of x equals 0.25, x to the third minus x squared minus 1. We're going to start with degree and leading coefficient. What is the degree? Is this in order? Okay, gotta make sure it's in order. What's my degree? 3. So that is all. Leading coefficient. 0.25, and that is positive. So it's odd and it's positive. Give me some homework. What's it going to look like if it's odd and positive? I can't read your mind, you guys show me. It's going to be reading up. I don't know what happens in the middle. Okay. But I know it looks like this. So we go to the left side, and we say that the f of x, the y values are going down, so negative infinity, as my x's are going to negative infinity, which means to the left. On the right side, my y's are going up, so positive infinity, as my x's are going to the right, so positive infinity. How many people think they're absolutely certain that they will remember all of this notation if they don't practice their homework? Yeah, that's what I thought. If you do not practice your homework, you will not remember the notation. It's not hard, you just have to practice it so you understand. If you're still not understanding something, come see me in study hall tomorrow. Yeah.
When we label it, we'll write it as a homework answer. No, we just write both of these, we just write both of them, or so left.
No, but if you wanted to write this is the left side, that's okay with me.
Okay.
You see how I even wrote it on the left of my picture? That's totally fine. The only time I would suggest you do.
Okay.
Because, you can do this, but it'd be easier to see on video.
Okay.
Okay. Last section. Got your calculator handy at home? We'll lead in one moment. Last section. We're going to graph it. It does not say what I'm going to be grading, so I'm going to tell you what I'm going to be grading when you graph it. First thing I'm going to be grading is that you find your y-intercept. How do you find your y-intercept? Plug in 0 for x. So you plug in 0 for x. X is 0, what's y? negative 3. Okay, I got 1 point in my graph. Next thing that you need to show me in your homework is you need to show me that you checked your degree and you checked your leading coefficient. Why? Why would we need our degree and leading coefficient? To know the end behavior. So that's the next thing you have to put in your homework. So the degree of this polynomial is 3. Make sure it's in the correct order before you say that. It is. And then the leading coefficient is -1. So degree tells me even or odd. This one's odd. Leading coefficient tells me positive or negative. This one's negative. So the end behavior, if it's odd and negative, would look like what? Like that. Now, other than that, if you want to find more points, you can plug in any number you want. And we could be graphing all day, but you're still not really going to be able to do that accurate. So we're going to look at our calculator and look at the table on the calculator. So go ahead and graph this on your calculator. And we can plot points, and you'll start to see the shape. But you're not going to be that accurate until you actually see it. You'll see why once you see it. So go to your y equals, type this in, ask me a question if you're having any issues typing it in. And then I might borrow somebody who has a color calculator so it shows up on the video. The dark ones won't show up. So you type in your y equals your equation. It is crazy, isn't it? Where can we go in our calculator to find points to plot? The table. Yeah. It's your graph too, but solve or whatever it is. Yeah. What is graph? It's just part of the same part of school. I'm borrowing somebody's graph. You can see if you get it right. So our graph should look like this. And if you go to your table, there's a bunch of points you could use. There's other points. If these aren't very accurate, there's another way you can get points besides just going to your table. If you go to graph, is this wrong? Yeah. Huh, awesome. Yeah, I know. Tim's over here like, oh, it's my calculator. We're about a squared. Oh, wait, now what? Oh, well, he wrote 2x instead of. Yeah. Okay, gotcha. Anyway, but we'll blame it on the calculator. That looks better. That looks more like it. Because I know it has like a little right there. Okay, I just want to show you, if you take your finger and you press the trace button, and I'll give it to you in a second so you can do it too. You press the trace button at the bottom, it tells you what ordered pairs it's sitting at, and if you use left or right arrows, it'll give you approximate ordered pairs at the bottom. So you can kind of find like the minimum and maximums, the little top of the bumps and the little bottom of the bumps, so you can plot it a little bit more accurately. If you have a graphing calculator and you can't make the graph accurate, I'm going to take off. Because like all the points are there for you. If you can't graph an accurate graph with these points, then you're just not trying that hard. So you hit trace and then use left or right arrows. So I kind of know where some of these points are already. Okay, so it looks kind of like that. We're going to the next one? Same thing, same thing. What do we need to know? What's the first thing we need to know? Y-intercept. What's my y-intercept to be? 0, 4. Graph it. Next thing is degree. What's the degree? 4. That is even. Leading coefficient is 1. That is positive. That means my end behavior if it's positive and even, we're going to have both sides up. I only have 1 point on the graph, so you're going to have to type it in to see what it looks like. Has everybody typed it in yet while I was talking? When somebody has it typed in, let me know and I'll put it under the video. Now, here, take one of these guys. Take one of those. I'm giving you more graphs than there are people, but you guys just hear that just they're all stuck together. You got it. There it is. Did you get it? Did you get it? Typed in? Who's got it typed in? Put it in the video. Here's what it should look like. Fun, huh? And you can find points by using trace. You can find some points by using trace, or you can use your table. But this one probably trace works better because most of the points are way off the graph. So you'll have a few graphs that you need to do, and I gave you some graph paper for that. The rest of it is just basically vocabulary, and it is in the book. It is not on Big Ideas, it is in the book. Write those numbers down, take a picture of those numbers. You can get on Canvas, the numbers will be on Canvas. The video will be on Canvas. Don't